Okay, so I want to go over a little bit of vocabulary before we do this little developmental activity. So we're going to start talking about proving specifically triangles congruent in different ways besides all their corresponding parts. First thing I want to go over is a little bit of vocabulary, like I said. A vertex, well, this is a vertex. It's where two sides meet, the point at which two sides meet. Okay, so these are all vertices, if you didn't know that. So it's where two sides meet. Okay, adjacent sides. Adjacent sides are sides that share an endpoint. Okay, so if we're talking about adjacent sides, AB and BC would be adjacent. Here's where things get a little bit dicey. So an included angle is the angle formed by two sides. So if I was talking about an included angle in this picture, if I said AC and BC, the included angle would be angle C. So angle C is the included angle of AC and BC. So it's at the endpoint where with the two sides. A non-included angle, that's going to be just a little bit different. So if I'm talking about angle B, well, angle B is the non-included angle of AC and AB because it's not between. Okay, not formed by the sides. Okay, and this one is formed by the sides. All right, and that's not the only location. There are different locations for this. An included side also. Okay, so an included side, if we're talking about AC, well, AC would be the included side of angle A and angle C. Okay, so the endpoints are vertices of the angle. And then the non-included side is going to be the non-included side. So if we're talking about AC in this case, well, this would be a non-included side of those angles, okay? Where basically the endpoint, only one endpoint is the vertex of one angle. Okay, so again, that's what non-included side, and this is going to definitely, it's going to be really big. It'll come into play. So last thing I want to talk about before I kind of let you guys go to do this activity is third angles theorem. So third angles theorem says if basically if I tell you angle E, if angle E is congruent to angle C, and if I told you angle F is congruent to angle B, you could conclude that the third angles have to be congruent to each other. That's what third angles theorem says. I'm just going to do a little proof really quickly in the video, just because I think it's good to do. So you know that the measure of angle E plus the measure of angle F plus the measure of angle G is equal to 180. You also know the measure of angle C plus the measure of angle B plus the measure of angle D is equal to 180. You should know, well, 180 is equal to 180, so the sum of the sides must be equal to each other. So the measure of angle E plus the measure of angle F plus the measure of angle G must be the same thing as the measure of angle C plus the measure of angle B plus the measure of angle D. Okay? So if that's true, well, I also have other pieces of information. I know that the measure of angle E is equal to the measure of angle C. So I can actually subtract those from each side. So that lets me, well, then that means the measure of angle F plus the measure of angle G is equal to the measure of angle B plus the measure of angle D. And then the next thing we know is F is congruent to B, so I know that the measure of angle F is equal to the measure of angle B, so I can actually subtract those from each side. Okay, and basically third angles theorem just says if two angles of one triangle are congruent to two angles of a second triangle, so two angles of one triangle are congruent to two angles of a second triangle, then their third angles are congruent. And so that's my conclusion here. The measure of angle G must be equal to the measure of angle D. And I just want to do the proof really quickly. So that's the first part. We'll continue